Welcome back, students. In this video, we are going to work on prime and composite numbers, and I'm going to talk about the trick we've been using in class, but I want to show it to you so you can play it over and over again because it might help you. Okay, so the first thing I'm going to do is I'm going to draw over here my C for composite. There's my C. I'm going to put a D with a 3, 6, 9 after it. I'm going to put an E for even. I'm going to put an F for 5, a Z for 0, and an S for 7. Okay, here's what we're going to do. We're going to look at our question, which says, which of these numbers is a composite number? Okay, we're going to go through each number and see if it's prime or composite. So let's go to 51. Okay, I'm going to go through all the criteria of this over here. So let's start with the easiest one, which is even. So is 51 even? It is not. Okay. Does 51 end in 5? That's what the F stands for. So I'm going to put a 5 instead of the F over here, but it's the same as the F. F stands for 5. Does 51 end in 5? It does not. Does 51 end in 0? That's what the Z is for. It does not. Is 51 divisible by 7? Well, let's check that. 7 into 51. I don't think so, because 7 times 7 is 49, and we're going to have a remainder. It has to be evenly divisible, and that's 7 remainder too. So it is not divisible by 7. Okay, the last thing we want to do is this D. That D stands for something called digital root. And the way we get to the digital root is we're going to take our numbers, which happen to be 5 and 1, and we're going to add them together. So 5 plus 1 equals 6. Okay, and is 6 divisible by 3, 6, or 9? It is. So let's start with 3. Okay, so can we divide 3 into 51? Well, let's just check it out. Can 3 fit into 5? Yes, it can. One time. 1 times 3 is 3. I'm going to subtract and get 2. Bring down my 1. Oops, that's a 1, not a 7. Okay, well, that's supposed to be a 21. Okay, that's not looking the best. Hang on, let me get my eraser and see if I can fix that. Let me make it smaller. Bear with me as I try to get a better one here. There we go. That's a little bit better one. Okay, so 21. 3 can go into 21 7 times. 7 times 3 is 21 with no remainder. Therefore, 51 is composite. So I'm going to put a C next to 51 while we go check the other numbers. Okay, so this was for A. Okay, so I'm just going to make this whole area was for A. Let's find a little area to work for B. We'll do it here. Okay, B is 53. So 53, let's go through our little, and I leave this C with all of these hints on the board. So there's no reason a student can't follow along, especially if they listen to this. So 53, is 53 even? No, it's not. Does it end in 5? No, it does not. Does it end in 0? It does not. Is it divisible by 7? Well, we just went through this, but let's try again. 7 into 53. I know we did it with 51, but 53, we can't even get to 8 yet. So 8 times 7 would be 56. So 7 times 7 is 49. We'd have a remainder of 4 this time. So 7 remainder 4. It's not divisible evenly by 7. Okay, and 5 plus 3. Let's check our digital root. 5 plus 3 equals 8. Can we divide 8 by 3, 6, or 9? We cannot evenly. That means 53 is a prime number. Okay, so we've done A and B. Okay, let's try another number here. Let's try C. We'll do C over here. Okay, and 59. Okay, so 59. Is 59 even? No, it is not. Does 59 end in 5? No, it does not. Does 59 end in 0? It does not. Is 59 divisible by 7? Well, let's take a look. 59 divided by 7. Can 7 fit into 5? It cannot. Okay, so 0 times 7 is 0. 5 minus 0 is 5. 59. Can we fit 7 into 59? We can. 8 times would be appropriate. 8 times 7 is 56. 56. We subtract. We get 3 as our remainder. 8 remainder 3 is not evenly divisible. And then finally, 5 plus 9 to get our digital root. 5 plus 9. And another thing, students, if your digital root is over 9, then you have to, let's say your digital root is 12 after you've, done all this. Your digital root is 12. You would have to take the 1 plus 2 because your digital root has to be less than 10, okay? So in this case, 5 plus 9 is 14, and we cannot divide 14 by 3, 6, or 9. Okay, it just doesn't work, not without remainders. So that means 59 is also prime. Okay, so how about 61? Let's do one more. Okay, 61. We'll do it all the way over here. D, 61. Is 61 even? No. Is 61 divisible by 5? No. Is it divisible by 0? No. Is it divisible by 7? No, because it would be 56 or 63. Neither works. The digital root would be 6 plus 1. Okay. 6 plus 1 equals 7. And that is not divisible by 3, 6, or 9. Not divisible by 3, 6, or 9. So therefore, 61 is also prime. Let's try a bigger number. I want to show you how to do the digital root on a bigger number. So let's say we do 91. 91. So 91, is it even? No. Is it, does it end in 5? No. Does it end in 0? No. Is it divisible by 7? Well, let's check. 91 divided by 7. Oh, it is. 1 times 7 is 7. Subtract. And you get 2, 1. So it's 13. Okay, well, that wasn't exactly my intention, but we showed that 91 is not prime. But if we want to check the digital root on 91, although it's not going to do us any good, we'd say 9 plus 1 equals 10. Okay, now 10's bigger than 9, so we have to go 1 plus 0 equals 1. So the digital root would be 1, and 1 is not divisible by 3, 6, or 9. So it's not divisible by 3, 6, or 9, but it is divisible by 7 when we tested it on the 7s. Okay, but that's how we find the digital root, which is, although it seems a bit tricky, once you practice it a few times, it's quite straightforward. Again, if your number that you get when you're getting that digital root is over 10, then you just add each digit together. So if it was like, let's say your digital root was 14, you'd add 1 plus 4. If your digital root was 17, you'd add 1 plus 8. Okay, if your digital root was 18, you'd add 1 plus 8, which would be 9. All right, thank you, class. So our answer here, by the way, was A. A was our composite number.